Hello everyone, my name is Huang from Computer Science Department. I want to represent our research group to introduce our recent research topic about weakly supervised object localization in image processing. Firstly, I will briefly introduce the background knowledge about object localization and weakly supervision using class activation maps and foreground prediction maps. Then I want to introduce the proposed method and show the results. Object localization is using a machine learning model to mark the location of objects in image. For example, here we can detect the bird by marking the bounding box for the bird. We can also detect the cancer region in ultrasound image. However, training this kind of machine learning model needs the bounding box annotations. However, bounding box annotations are hard to acquire. Therefore, we want to use other supervision methods to train this kind of model, which is weakly supervised object localization. Typically, we will use class labels to train a classification network for weakly supervised object localization. A class activation map is computed based on the last convolutional features and the weight parameters from the fullest connected layers. For each class, we will get one CAM. The CAM is a heat map that can detect the foreground regions for classifying this class. However, this CAM is highly related on the accuracy of classification result. In order to avoid the dependency on the classification accuracy, we use foreground prediction maps. We firstly sort the class activation map for all classes in descending order and then use the top 80 classes average value to represent the FPM. The FPM is also a heat map for foreground, and then we can set a threshold for generate the localization bounding box. Traditional classification network cannot generate high-performance FPMs, so we propose a new network structure, including two branches. Majorly, the first one is for the classification, and the second one is for the localization. In the localization branch, in order to refine the FPMs, we propose two modules. The first one is the NLM model, and the second one is the FPM fusion model. Because of the time limitation, I will not include them here. The proposed methods are evaluated on two public datasets, which are the CUP200 and the IRSVRC 2016 dataset. Our method achieved the best weakly supervised object localization result comparing with existing methods. Finally, I would like to thank the funding agency. This work was supported in part by the Google Cassie Institutional Research Award. And this is the end of our presentation. And if you have any question, please reach out by our emails.